Welcome to Earth Science. Here we go. So you should have one of these globes in front of you, and it will, I deliberately don't have the line on there yet, but it will have a line on there. And you should be on this section of the lab, and I know that looking at the screen through this camera is not fantastic, but we'll fight through it. You can do it. What you're going to need to do is follow these steps that are right here. So step one, set up your globe so that north, south, east, and west look just like they do on that paper right there. So I have it backwards right now. I have south on the left, north over there. So we'll do it like that so that what I'm seeing on this globe ends up getting onto your paper. The goal is to make this three-dimensional object go onto that two-dimensional piece of paper. And by piece of paper, I mean your lab on Kami. Using the external protractor, the blue thing, one of these guys, let's measure how high in the sky the sun reached at its peak. Now, here in New York, like everywhere else in the Northern Hemisphere, the sun's path is tilted towards the south because it's overhead down there in the south towards the equator. What we're going to want to do is figure out how high it is. So there's going to be a line here by the time you do this lab. We'll figure that out. To do that, take this protractor, which has numbers on here, start with the 0 ends, put the 0 end on the ground, put it on the globe just like that, it fits like a glove, and tell me how high in the sky is that path. Now, I'm gonna be wrong deliberately. Don't copy my work. I'm gonna say it's 80, which it's not even close to. So what you would do if it was 80, which it's not, is put a dot using Kami, well, maybe size 6 or so, up there at 80, like that. Now yours won't be that. Yours will be where it actually is here in New York on that day that we did this lab, but close enough. Next, mark where the sunrise was and the sunset was. So again, over here in the west will be the sunset, and there will be a line that comes down. You can see some of the old ones on there from past years. And over here in the east, there will be a line where it starts. What I want you to do is eyeball about where that is, and like looking at the diagram like this, and I'm not saying it's easy, but it is our job. Looking at the diagram like this, try to estimate about where that sunrise is. If it were the equinox that we did this, if it wasn't cloudy that day, it would be exactly east to exactly west. We didn't. We were off by a little bit, so mark about where you see it. I'll do it as if it were the equinox, which again it wasn't, so don't copy me. It would have been exactly east to exactly west. So there are really the only 3 dots you need. Again, yours will be different than that because I did it on a different day. Don't just steal off my video. Do your own work based on your plastic globe. Okay? That's it. The next step is connect the dots, but what I think I'll do is go back to Screencastify to do that and do the next section of the lab there because this camera is not perfect. Sound good? Whoop, I knocked him over. Sound good to you? All right. Welcome to Earth Science. We'll see you in part 3.